We're looking at figure 4.4, page 78 and 79 of your textbook. The first thing we look at is this table given to you that explains the story of a nearby lake that's polluted, and there are 3 houses on this lake, house A, B and C, and the owners are willing to pay a certain amount, meaning they have a demand for cleaner water. So the water is polluted. Homeowner A says a high level of contaminants. He will pay 110 to reduce that. Then the further it goes down, the less pollution there are in the is in the lake. So does his willingness to pay for cleaning it up also decreases. So that makes sense. If the river is very polluted, you're willing to pay to just get it a bit better. And as it gets closer to perfect, you feel it's livable. You can handle a little bit of pollution. So it's the same for everybody. Initially, when the lake is really polluted, they're willing to pay a lot to clean it up. And as the lake's quality increases, their willingness to pay decreases. So here as well, initially a high willingness to pay to clean it up, and then as the river gets cleaner, a lower willingness to pay to clean it up. So let's look at the graph of the first homeowner. Here we can see it very clearly. The homeowner, this information is drawn. So over here we wrote from 4 to 0, meaning it's a higher level of cleanliness. So here is the river is very polluted, so it's a high pollution. And here is a low pollution, right? So that's why it's wrong way around, is to show from high to low pollution. And then you'll see this information over here is given to you with this graph. So for to clean up 4 levels of pollution, you pay around here, which is 110. 3 levels of pollution around here, which is 85, etc. 2 levels is around here 70, and 1 level is around here somewhere 55, etc. Okay, so this curve over here shows his demand for cleaner water. Next one. So from the moment we saw this homeowner B, we saw he has a smaller demand for clean water because initially he will not pay as much, it's only 60 to clean the water, and then after 2 units of pollution, he doesn't even care anymore and he doesn't want to pay anything, right? So 0 to, so you can see a much flatter and much lower curve than homeowner A. And then lastly, homeowner C, we saw him as well, even more so. He started with a very low demand for cleaner water, but at least he felt till the end he wants to pay something to clean the water all the way to 0 pollutants. And so you can also see a flat line, but it goes on a little bit longer. Right. Now the graph just tries to show the 3 homeowners underneath each other, right? And then it shows how we added the total demand for clean water. So at homeowner A, for level of 3 units of pollution in the water, is willing to pay, what was it, 85. So it's 85 plus 30, I think. No, 35, sorry. And then just refer back to your table. And then over here we had a value of 20. And if you add all that together, you get a value of let me just check again, where is it, 140. So we can see 140 over here, more or less, right, to produce it to the willingness to pay, the demand to get the lake's water quality up to 3 units of pollution. So this demand curve just adds all these curves together to get this aggregate demand for clean water. The other curve, the marginal cost curve, means what's the cost of cleaning the river. Now, cost initially of cleaning, it's quite cheap initially to clean the river from pollutants, because there's a lot of pollution, so you can use simple methods to get the pollution out. But as the pollution decreases, the cost of reducing it further increases. Why? Because now you have to apply much more sophisticated methods to get that last bit of pollution out of the lake, and that's why the price then increases. Now you can see in the table there was a column called marginal cost of cleanup, and you can see it starts initially low and then it increases quite drastically. It's because initially there's a lot of pollution, so it's easy to take some out, and as the pollution decreases, it gets more and more expensive to take the pollution out. So, and that's why this curve has a positive slope. Over here they intersect, and they're both, I think it was 95, refer back to your table, at 2 levels of pollution. So this is the efficient level of pollution, meaning this is the amount the homeowners would feel they are willing to pay for that. Yes, I'm willing to pay this amount, and for the costs involved of doing that. Right. If they decrease the pollution even further to, let's say, 1 unit, the cost of reducing it is higher than the demand for the clean water. So they won't go that way. And they won't stay on 3 as well, for example, because the cost of producing it further is lower than the demand for the reduction. So they will be willing to pay more to get that 3rd unit of pollution away and to end over here.